So today we're going to jump into the rock cycle. We're going to talk about the three different types of rocks that we have here on Earth: igneous, sedimentary, and metamorphic. And we're going to talk about how each is created, how the rock cycle transforms one type of rock into another, and where we would expect to find these different types of rocks around different places on Earth. I'm sure most of you have heard about the rock cycle, even if it's been a few years since you really thought about it. But the rock cycle is how different types of rocks on Earth are transformed into other types. We have three major types: igneous, that form from lava or magma cooling down into solid rock. We have sedimentary rocks, which generally form from pieces of sediment getting compacted and cemented together over time. And then we have metamorphic rocks, those that are formed from intense heat and pressure inside of the planet. But we generally think of the rock cycle as, let's say, metamorphic going to igneous, going to sedimentary, back to metamorphic. But in fact, the rock cycle, we can have any type of rock being transformed into any other type of rock, as long as we have those transformations going on. And this will make more sense a few slides down the line. But the first type of rock that we're going to focus on today are igneous rocks. And these form from magma, either inside of the earth or lava at the surface. So regardless of whether we're talking about magma or lava, this is basically where we have melted rock. It's going to form kind of like a thick fluid, and it moves around inside of Earth's upper mantle and through parts of our crust. And we can see it erupting at the surface as lava, especially if we think about a volcanic eruption, which we'll get to in a couple more chapters. But as that liquid lava is cooling down and turning into a solid, we have crystallization occurring. And this is where individual crystals of minerals start to grow. And eventually this lava will be completely cooled into a solid, and at that point it will be called an igneous rock. So if that igneous rock that formed from that cooled down and now solid lava is exposed at Earth's surface, it's going to be weathered. And weathering is something that happens just from the atmosphere, like literal weather. Over hundreds, thousands, and millions of years, if you allow enough rain to hit a rock or a wind to hit it, it's going to break it down into smaller pieces. And this is just known as weathering. And overall, it just creates loose material, and if it gets small enough, it can dissolve that material away. But all of that loose material is called sediment. And this is going to start forming our second major type of rock, our sedimentary rock. But in order for this to happen, that loose sediment has to be moved somewhere else. It can be moved by things like gravity pulling it down the side of a mountain, by waters running downstream, by wind and waves at the beach moving all of this loose sediment around. But eventually that sediment is going to be deposited. It's just going to be left behind in some new environment. And over time, all of that loose sediment that's been deposited in a new area is going to lithify. It's going to go from loose sediment into a solid rock, by being compacted into a smaller space, and by cementation, where we're going to basically glue each piece of sediment together into one solid rock. But over time, plate tectonics is going to affect this sedimentary rock. If it's exposed to a lot of heat and pressure, especially if it's incorporated inside of a mountain change, it's going to transform into our third type of rock, metamorphic rocks. And this happens through metamorphism. And metamorphism is just a way to say change. So with metamorphic rocks, we're seeing them change because they're exposed to heat and pressure. But eventually, with enough heat and pressure, that metamorphic rock is going to melt back into magma, in which case we're going to start cycling back through our rock cycle at igneous rocks and complete the cycle again. So we can see here each part of our rock cycle. We're starting off with liquid lava or magma that's going to cool down and crystallize into solid igneous rock. That igneous rock is going to be broken down into loose sediment by weather over really long periods of time. But eventually, all of this loose sediment is eventually going to be deposited somewhere else, where it's going to lithify, where it's going to be squeezed under pressure, and it's going to glue all of the sediment together as a solid rock. But eventually, that sedimentary rock is going to be exposed to heat and pressure, which is going to change or metamorphose it into a metamorphic rock. And with enough heat and pressure, that metamorphic rock can melt back into lava or magma, completing the cycle. So if we think about rocks on a human timescale, they don't really change much day to day. But our rock cycle happens on a geologic timescale. So instead of thinking about years or decades, think about millions and sometimes billions of years. And over these really long periods of time, rocks aren't stable. They're constantly changing. It just happens that the rock cycle moves at a super slow pace. But we're seeing that different stages of the rock cycle are occurring in different parts of the world right now. If we wanted to look for new igneous rocks, we could go to Hawaii and see where Kilauea is erupting, releasing lava that's cooling down and solidifying. If we want to look for new sedimentary rocks, we might want to go look around the base of the Colorado's mountain chain known as the Rockies. And if we're looking for metamorphic rocks, we might want to go to the Himalayas where Mount Everest is growing. But unlike a lot of what we've been taught in middle and high school, the rock cycle does not have to follow that exact step. As long as we have igneous rocks forming from lava or magma, sedimentary rocks forming from sediment and lithification, and metamorphic rocks forming from heat and pressure, we can transform any type of rock into any other type of rock. So for example, if I had an igneous rock and I melted it back into magma and just let it re-solidify, it could turn into a new igneous rock without having to become a sedimentary and then metamorphic first. So it doesn't have to go around this cycle. As long as those geologic processes are in place, we can form any type of rock from any other type of rock. And the rock cycle will continue on our planet for billions of years. The reason why we have the rock cycle is because of Earth's core. It's insanely hot, and it produces a lot of heat that's wanting to escape this really hot area. So the heat from our core causes the magma to move around in our mantle. Think about a boiling pot of water. The hot water at the bottom is going to rise towards the surface of the pot. The same thing happens in our planet. That really hot magma close to the core is going to rise closer to the surface. This is going to cause plate tectonics, which is the focus of our next chapter. But as long as we have that internal heat from our core, the rock cycle will continue. And as long as we still have an atmosphere and weather, things like wind and precipitation, producing our sedimentary rocks, the rock cycle will continue for billions of years into Earth's future.